And welcome back, students. Let's continue talking about arrays and references. Today we're going to discuss that arrays are objects. So getting started. Just like a variable of one of the many type of classes we've seen, a variable of an array type will hold a reference. In this section, we'll explore the consequences of this fact, including a discussion of array parameters, which we actually will kind of touch a little bit at this time, but we'll talk about a little bit more next time when we specifically talk about array parameters. Now, we will see that arrays are objects and that array types can be considered class types, but somewhat different types of class types than what we're used to. So, arrays are objects. There are two ways to view an array. You can either view it as a collection of index variables, which is how we've been viewing them, or as a single item whose value is a collection of values of the base type. At the start of this chapter, we discussed using arrays as a collection of index values. And that's how we approached creating the array. We're now going to discuss it, though, from the second point of view, treating the array as an object. Even though we kind of a little bit been doing that, we're going to really kind of hammer that on a little bit more. Now, an array can be viewed as a single item whose collection of values is of the base type. That is the second viewpoint here. And a array variable, as opposed to array index variable, names the array as a single item. So, for example, the following will declare an array of type. So we have double A. This variable A can and will contain a single value. The expression new double 10 creates an array object and stores the object in memory. The following assignment statement places a reference to the memory address of this array object in variable A. So A equals new double 10. Typically, we will combine this all into a single statement as follows: double array A is equal to new double 10. You can see syntactically, it's not really any different than how we've been creating our arrays. It's more of just the thought process behind how we're creating these arrays. Syntax-wise, it's the exact same, but how we approach the methodology of using the array is going to be slightly different. Now, like I said, notice it's almost the exact same way that's the way we view objects of a class type. In Java, an array is considered an object. Whenever Java documentation says that something applies to object, it means it applies to arrays as well as objects of the class types that we've seen up to now. You will eventually see examples of methods that can take arguments that may be objects of any kind. These methods will accept array objects as arguments as well as the objects of an ordinary class type. Arrays are somewhat peculiar, though, in how they relate to classes. Now, some people argue that the array types themselves are not classes. Some say they are, but pretty much all authorities will agree that arrays are objects. Me personally, I'm not saying. I think arrays are simply just an object type. I don't necessarily think they're a class, right? Because they only really have one method, which is that of the length method. All right. Now, given that arrays are objects, it seems that one should view array types as classes, and we will do so. So even though we may not view them as being a class type, we're going to still treat them as though they were. Now, however, although an array type double is a class, the syntax for creating an array object is a bit different. So to create an array, we use the following syntax: double A equals new double 10. All right, just like how we've been making an array. Now, you can view the expression new double 10 as an indicator of a constructor that uses a non-standard syntax. Right, so this is where we're going to start breaking down the construction of the array. All right, so because we have to use the new operator. Remember when we had class objects, if I wanted to create a new instance of that class object, I'd have to use the new operator. Here, notice with our arrays, we have to use the new operator as well. And so that's why there is an argument that yes, arrays are a type of class. As we've already seen, every array has an instance variable named length, which is a good example of viewing an array as an object. So, like I said, we talked about array length. Uses just get the array of the length of the array. And as with any other class type, array variables contain memory addresses, or as they usually called in Java, references. So every variable at those different index positions that you make inside of an array. So array at 0, 1, 2, etc. Those all are containing a memory address in order to store that information. So array types truly are reference types. Now, since an array is an object, you might be tempted to think of the index variables arrays, such as A0, A1, and so forth, as being instance variables of the object, which is kind of how we might think about it normally with classes. However, while this is a good analogy, it is not literally true. Right? If you recall, index variables are not instance variables of the array. Index variables are instead, when we talk about classes, a special kind of variable peculiar to arrays, because how arrays handle them is very different. In fact, there's only one instance variable in the array, which is the length instance variable, which we've talked about back in 6.2. Otherwise, we don't have any other instance variables. You don't have, you can't go and create like a private int or private double or anything like that. Now, an array object is a collection of items of the base type. Right? So whatever your base type is, if you recall, that's like int, double, string, the class type. Now, viewed as such, an array of an object that can be assigned with the assignment operator and plugged in for a parameter of array type. Now, because an array is a reference type, the behaviors of arrays with respect to equals or equals equals and parameter passing mechanisms are all the same as what we've already described for classes. Right? One of the big things is that, remember, equals equals is going to test the memory location. It's going to test the reference. It's not going to test to see if two objects are actually containing the same values. If we talk about classes, remember we had to use dot equals in order to test to see if the class objects were the same. Similar things are going to happen here with arrays. In the next few subsections, as we start getting into later pieces here, we're actually going to discuss these details about how you would do these different actions inside of arrays. All right, now before we close off today, we do have a pitfall to talk about, which is that of arrays with a class base type. The base type of an array can be any type, right, including class type. We've already talked about this. So you could have one that's of the person class, or you could use our Android person class from our labs. Now, for example, suppose date is a class, and consider the following. Date holiday list equals new date 20. This will create the 20 index variables, holiday list 0, holiday list 1, etc., all the way up to holiday list 19. It is important to note also that this creates 20 index variables of type date, but it does not create 20 objects of type date. Technically, there's only one, which is holiday list. All right, you have 20 index variables, but not 20 objects. You only have one object. The index variables are automatically initialized to null, not to an object of the class date. Like any other variable of type date, the index variables require an invocation of a constructor using new to create an object. So what that means is that if we want to complete that, we can use an array such as the following. So date holiday list equals new date 20. Right, that's going to create our 20 things. For int I equals 0, I is less than holiday list dot length I plus plus. Holiday list I equals new date. And that is an invocation then of the date constructor. So if you remember the date constructor, you would then get in, a set of values. Because if there's not anything predefined in our date constructor, remember we had our constructor method, and it would have predefined values there if you just did new date. Otherwise, it initializes it all. If you don't have that constructor method in your class, then those values are going to be kept as null. But however you've made the constructor method in your class, then whatever you predefined in those values is going to be set in there. All right, continuing onward, if you omit that for loop and you do not do something else or more or less equivalent, then when you run your code, you're undoubtedly going to get an error message indicating a null pointer exception. If you do not use new to create an object, right, that's where we had like new date and all that stuff, an index variable like holiday list is just a variable that names no object and hence can't really be used as the calling object for any method. Whenever you're using an array, therefore, with a class-based type and you get an error message referring to a null pointer exception, it's likely that your index variables do not name any objects and you'll need something such as the above for loop to be added into your code. Because like I said, if you look back at our original code here, when we looked at this, and we just say how did this new date 20, remember, these are just creating the index variables. Those index variables were all set to null because you have to go through and create the actual date object themselves. It creates 20 date objects that aren't really objects, they're just variables of it, However, they don't actually contain values unless you use something like this for loop here to actually hold those values. All right. And I think that's a wrap for today, folks. So we will see you next time.